Alright, we want to do a partial fraction technique on the fraction numerator 2x plus 2, denominator x squared minus 2x plus 1. So the first thing is to make sure it's a proper fraction. The degree of the denominator is 2, degree of the numerator is 1, so it is. The next thing is to factor the denominator completely. X squared minus 2x plus 1 is x minus 1 times x minus 1. So more or less this is a repeating factor in the denominator. We can write it as x minus 1 quantity squared. And now we are at a point where we want to try and break this down into simpler fractions. So let's see. 2x plus 2 in the numerator over denominator of x minus 1 squared. So we need to set up the denominator. The simplest factor here is x minus 1, but it is repeated, so it's going to show up in every power of the repetition. So it's repeated twice, so x minus 1 is one factor, and x minus 1 quantity squared will be a second factor, or a second fraction. So look at the true factor, x minus 1. That's degree 1, so the numerator needs to be a constant, 1 degree less, so it'll just be a. And we're going to use that same setup for each repetition of that factor. We need a new name for it, so we'll just use b for the one with the x minus 1 quantity squared. So this is the setup. Now what we got to do is we got to go through and actually break this down and figure out what the a and the b are. So we'll multiply through by our common denominator, which is x minus 1 quantity squared. Okay, so let's see. That's going to knock it out of the the left-hand side. It's going to knock one of them out of the single factor, and it'll knock both of them out of the double factor. So let's see. That cleans up to have the equation 2x plus 2 on the left, and on the right we'll have a times x minus 1, which I'll write as ax minus a, and then plus b times 1, which will just be b. So let's see what we've got here. We've got some terms to the first, so we'll just have the x term, and there'll be 2 of those on the left and a of them on the right. So we now know that a is 2. We've already solved for one variable. Let's go back and color code this so you don't lose it. And then we'll do the constant. On the left we have 2, and on the right we have negative a plus b. And since we already know that a is 2, that means negative 2 plus b equals 2. So it looks like b equals 4. So this partial fraction breakdown turns into what looks to be 2 over x minus 1 plus 4 over x minus 1 quantity squared. Now, as we said, if we were trying to, got a little slow down here, if we were trying to integrate this, we could integrate these things over here separately. So we got simpler fractions to work with. Both of these are a u substitution type problem, but the first one is a little bit simpler. The first one is a natural log, so it just gives me 2 times the natural log of x minus 1. The second one, the 4 over x minus 1 squared, it's a u substitution. Might be better to write it out. U equals x minus 1, du equals dx. So then we're integrating 4 over u squared du, which is the same as integrating 4 times u to the negative 2. So that would be u to the negative 1 times negative 4. So if we take that u back to what it was, the x minus 1, we'll have minus 4 times x minus 1 to the negative 1. And don't forget my plus c. So if this all works out, you'll have 2 natural log of x minus 1 minus 4 over x minus 1 plus c. Okay. If you carry it to the integration process, I believe we've got the answer we want. Thank you.